Welcome to Living on the Edge. What if I told you that you can not only help boost your application's performance with minimal architectural changes needed to your web applications, but that you could also help fight climate change by doing so? That'd be pretty awesome, right? I feel like most of us would take that kind of deal in a heartbeat. But a lot of technology makes these bold claims about these things that they're able to do, while not so infrequently, glossing over their limitations. But I hope that once we're done today, you'll be as excited as I am about the rise of an edge-first future and start adopting the edge in your own applications. But we have to first start off with what is the edge? And unfortunately, it's a bit of an overloaded term today. Some folks think that I'm referring to the network edge when I'm talking about the edge, and that's still a valid use of the term today. I think this dates back to the 90s, and that's where enterprise networks connect to third-party services. And while that's still valid, what we're talking about when we're talking about the edge today is a location, where application logic is run and where data is hosted, much closer to our users than it generally tends to be today. You might also see the term points of presence or POPs or edge locations to refer to the edge. They all mean the same thing at the end of the day. Now, because I could probably fill a whole hour talking about all the modern versions of the edge, and we only have 25 minutes, we're going to take a look at the edge in a cloud computing context, because that's generally, as web and full stack developers, what we're mainly going to be working with. So I'm going to take a quick step back and talk about how cloud providers organize their data centers. And on the broadest possible scope, cloud providers organize their data centers by region. So Ireland actually is a region, EU West 1 more specifically, and let's say AWS's network. And within each region, there are multiple availability zones, or AZs, and they all contain one or more data centers. And this is generally where our application logic is run and where our data is hosted. And when we talk about origin servers, we're typically talking about these servers, because that's where those things are run. And taking a look at this next image here, which show all, as these yellow orangish dots, all the availability zones in Amazon's network, we can take a pretty educated guess at which users are getting the best performance of our services. And you can see that we have like a cluster of, that didn't work as I wanted. You can see a cluster of them in Europe, as well as some on the east and west coast of North America. And regardless of whether you have a single instance running in one AZ or multiple instances of your application, the users that are closest to those AZs will get the best performance, and the ones that are furthest away will get the worst, just due to the request latency that's incurred from receiving and fulfilling the request. Now, the edge in a cloud computing context refers to data centers that live outside of this network. There's a lot more of them in the world, and because there's so many more of them, they tend to be closer to our users in a geographic sense. And we can see just how many more there are in the world by taking a look at this map. So the blue dots indicate individual edge locations, the purple ones denote multiple ones, and those yellowish orangish circles represent regional edge caches. Because the edge has, or these edge servers have smaller caches available, they give you a little bit of wiggle room before you have to make a request to a very distant origin server. So if you can handle a user request in its entirety, or even part of it in the edge network, you will get significantly faster performance from your applications due to the reduced request latency that's being incurred. And the regions that in particular benefit from this are South America, Australia, and Africa, because you can see here that they have multiple edge locations, and in the case of Australia and South America, they have a regional edge cache, but they only have one availability zone. So if you have, let's say, a user that's located in the northern or central part of Africa, and you have business or legal requirements that require you to host the data and run your application in the same region as which your user is located in, that's quite a distance that that request has to travel. But if you can do it at the edge, there's that edge node that's on the eastern part of Africa there, and so the request will be much, much faster than if you were to handle that request without using the edge. So now that we've got all that context, I want to talk about where the edge fits into the request lifecycle. So without it, this is a basic example of what a request would look like. We've got a user. It could be someone interacting with your services on their laptop on your website. Maybe they are interacting with a mobile application. Maybe it's just doing some stuff on a smartwatch. Whatever it tends to be. The request goes to the origin server, comes back. Now the edge, which is represented by this red diamond here, it works as a bit of a man in the middle. So the request will come in, and the edge location closest to the user will be the first spot to pick that up. Now, best case scenario, the edge is able to handle the request in its entirety and sends a response back to the user. But let's say that it can't. Let's say that you have a new deploy that just went out, and so you've had to recreate all your app bundles, and the edge doesn't have a cached version of that. It'll make a request to the origin server as per usual. It'll send the response back, and if you can, you would want to try and cache that response. Because if it is something like a localized app bundle, the edge location that's closest to the users is going to be that first place to start handling that request, and so other users that are making requests through your edge network will want that exact same thing. And so those other users will get like blazing fast performance once it's cached at the edge. And then at that point, the edge sends the response back to the user. So pretty straightforward, not crazy rocket science. But now that we can see where it fits into the request lifecycle, let's take a look at a sample web application, because most of us are working in legacy systems, right? And we can start to see how easy it is to start adopting it and getting those performance gains. Now, for a moment, let's imagine that rather than me working as a software developer in my day job, I instead have a thriving global e-commerce business that is run on a Next.js application that sells pet supplies that I've named after my dog, Ada, called Ada's Pet Supplies. It's got, the most popular items or stuff that I'm trying to upsell on this homepage here. And then I want to show different content to users based on where they're located in the world. And I do that by showing this banner at the very top. So this could be, friendly hello world message, not hello world per se, but like welcome to my site. It could be promoting a sale. Maybe it is letting a user know that there is a new storefront that opened up close by to where they live. So normally, how I would do this, at least in Next.js, is I would have to get the user's location from the Next.js middleware that's running on an origin server and an AZ. And then I would have to update the request somehow to pass that to a server-side rendered page and then render the HTML appropriately before sending the response back to the user. So let's take a look at what that code would look like without the edge. So we're going to start building our middleware function, running in an AZ. We get the country of the user from this geo object that comes from the request. And then from there, I add the value of the country as a query parameter, and then rewrite the request, and the server-side rendered page does its magic, renders the correct message, sends the response back to the user. The downside to this approach is that the server has to render this every single time. This is not cacheable. And because this is a very popular page on my service, the home page, this needs to be as performant as I can possibly make it. And so in a perfect world, I want this server-side rendered page to be a static one, so I can cache it at the Content Delivery Network, or CDN, for faster access going forward. And then that'll reduce the load that's on my server. And where the edge comes into this is I can inject that dynamic content into the static page instead. So let's take a look at what that looks like in code. Now, it starts off the same, and though you can't really see any difference code-wise, this is running on the edge now. So we're getting the country, again, off the geo object, which is coming off the request. And then from there, I have this new middleware request line. We're going to put a pin in that for just 1 second. We'll get to that in a moment. But I want to draw your attention to the line right below that, await request.next. What's happening there is that is making a request to the origin, but instead of it actually hitting my origin server in an AZ, it's getting the cache static asset that was put there at build time. And so the value of response will be whatever the page is that we've defined in the static page. So let's say it's just like a default welcome to my site message. Now, to celebrate me being here at JSDayIE, I want to give my fellow Canadians 50% off their order. So assuming that the user is based in Canada, I update the message to be what it needs to be. And then from there, this is where that new middleware request stuff starts coming in. So it's got 2 methods in there that I want to use. The first is replace text. What's happening there is that is updating the text in the HTML document itself to be the message that I need it to be. So that's the promo code. And then set page prop is updating the Next.js props before sending the response back to the user. So to recap on all the benefits that we get from making this very simple change, we now no longer have a server-side rendered page. We have a static page that is cached at the CDN at build time. instead of a page being rendered every single time a user makes a request for this page. We now have the request starting to get handled sooner because the middleware function is at the edge, physically closer to a user, so reduce request latency. And although I'm not doing it in this function right now, in this code, you could cache this response because it's likely that other users in that area will want this exact same response. So a lot of little performance boosts here and there, but they add up to a very meaningful difference when they're applied to very high traffic pieces of functionality. Now, we've talked about how there are individual requests leaving the edge functions in our various examples so far. But often it's the case that we'll have some sort of piece of functionality that needs to make multiple requests. And there are times where the default behavior of the edge actually works against you in that case, because those requests could be going somewhere a little bit further away and actually lead to an increase in overall request latency than if you made the request without the edge. Fortunately, this is a common enough problem that there are folks working on it, and there's actually a solution out there today that people can try if this is kind of their use case and they want to look at using the edge. And it's specifically the smart placement feature that Cloudflare released a few months ago. So to use an example, so the worker here is Cloudflare's edge function offering. So a user in Sydney, Australia makes a request, the edge worker picks it up, and now it's making a bunch of requests to Germany, which is very far away. That's a lot of request latency being incurred in that request. What smart placement will do is it will monitor the outbound requests of the worker. It'll just notice where it's making the majority of requests, and it will relocate that edge worker to be much closer to where it's making the majority of requests. So you go from something like this to something like this. So you'll still get faster performance. It'll reduce the overall request latency, but you're not going to be as impacted by making those multiple requests to that database in Germany. Now, speaking of databases, there was, I think it was last year, a member of the Remix Framework team wrote this great blog post that was saying that it doesn't matter how much of your application is on the edge with respect to performance if your data is still living at a very distant origin server. And so the next frontier in terms of boosting performance using the edge is not just about the application. It's actually focusing on how to access and store data at the edge closer to our users. And historically, there's been a couple of challenges with doing that. The first is the limited number of connections available on a database. How do you ensure that when you've got hundreds of thousands of edge functions and serverless functions that are spinning up, how do you ensure that the database has enough connections that it doesn't fall over? And then the other bit to this is data consistency. If you update data in one area of the world, how do you ensure that edge locations in other areas of the world have their data invalidated and updated in a timely manner? So these are classic database problems. And there's been two general approaches that I've seen with accessing and storing data at the edge. The one is a single source of truth approach, where you will access the database that is just your standard single database through a connection pool and using internal networks in order to manage all the incoming requests and speed up those requests. And the other approach is a more distributed data approach. So we'll take a look at both, but we're going to start with the single source of truth one. And the couple of examples that I want to touch on here are Prisma's data proxy, which is the diagram that you see up here, and PlanetScale. Prisma, with their data proxy, what they do is they manage the connection pool in this external data proxy. If you're trying to access data at the edge or another serverless function, you would access the data through this proxy and get your response back. PlanetScale uses their connection pooling at a lower level, more on the database level, actually, using their database clustering software that is open source called Vitess. And so as the database starts handling more and more traffic, the clustering software scales with the database. And so they're able to handle these ridiculous numbers of open connections. And in their load testing, they were able to handle 1 million open connections without the database even breaking a sweat. If you want to read more on that, they have a great blog post on it. Highly recommend that for reading. And then for making the request to the database itself, they handle the request over their internal networks. So it's much faster to fulfill than if you just had making a standard request over the open internet. Now, to switch gears to the distributed data approach, Cloudflare Durable Objects is the example I want to use here. So what serverless functions are to web applications, durable objects are to databases. They are globally distributed, unique pieces of data that live in edge locations close to the user. Because they're globally unique and they can only see and modify their own data, they ensure that they have strongly consistent data, which is always a bit of a concern when you're dealing with the scale that you're dealing with serverless and edge functions. The downside to this approach is that because these are little pieces of data scattered all over the world, you as a developer will have to stitch that data together on an application level. But with that being said, you would be accessing these through Cloudflare's network, and so that those requests will be very fast. Now, I'm not sure if anyone who knows who this is. This is a bit of a, yeah? I just missed this, to be fair. This is a cartoon from the, I think, late 80s, early 90s, called Captain Planet. My friend led me onto him over a Halloween one year, which is great foreshadowing for this next section, which is, now that we've seen how the edge can help boost the performance of our application, how we can access and host data at the edge, I want to bring us back to the other part of my question that I asked at the beginning, which is, how does edge computing help us fight climate change? And I want to open this section with a quote that I saw at another conference. It was Sarah Bergman at Microsoft. Her talk was, "Can green software help solve the climate crisis?" So I'm going to put that up and give you all a few moments to take a look at that. That's wild, right? That's like, I think the transportation industry is one of those industries that a lot of us look at as like the bar for like big carbon emitters. So the fact that our industry, ICT, it was on track to account for more than half of the current relative contribution for the whole transportation sector and I want to call it when this paper was published in 2018, is just crazy. And so much has changed since then, just in the past, not even the past year alone. With the rise of AI, where we're starting, like running AI models has become so much more accessible, where we're starting to incorporate AI in so many of our services, it's not unreasonable to think that we're gonna increase that number, and at a faster clip than maybe we're all expecting. And I don't know about you all, like I've maybe been working full-time in software for about 10 years, so like not that long, but not like too new either. But I was never taught to think about this when building software. I was taught more, because I come from more of a startup background, how to get something out sooner, how to optimize code to, you know, get to where you need to be in a short amount of time. And while, you know, that's still important, right? We still need to consider the impact that our software is having on the planet. And I think that, like, just in general, we need to actually start thinking about this a little bit more. The International Energy Agency based here in Europe put out this great report on cloud computing's energy consumption, and they broke it down in a very helpful way for our purposes. Because what I want to highlight as 3 areas that the edge can help us in fighting climate change and in reducing our software's carbon emissions is in these 3 areas. Because as we saw in our examples earlier, if we can start handling things at the edge, that means that our data centers need to do less work. So we reduce the amount of energy consumed from those workloads. If they need to do less work, it maybe means that we need less, we can reduce the size of the machines that are there as well, reducing the energy use even further. If we're hosting data at the edge, then we can maybe even reduce the size of the databases that we have in our AZs as well. And the data transmission network energy use, that's just a fancy way of saying the energy consumed when we're in the middle of sending things over the wire. If we're hosting our applications and running our logic and storing our data closer to our users, and they don't have to wait as long for responses to come back to them, we're consuming less electricity and energy and reducing the carbon emissions of just waiting for a response. And so these are all small things, but they add up to a meaningful difference when we apply them at scale and in high traffic pieces of functionality. Now, I know that I've spoken about a lot of cool things about the edge so far, but I'd be remiss if I didn't talk about some of the limitations that's inherent in the edge right now. So the first thing I want to call out is that there's lower CPU time available in edge functions. That's not the same as wall clock time. It just means that you can do less operations in these edge functions than you can do in a normal serverless function. We've talked about how you're able to make network requests from the edge, and it's likely that you will have to if you were to start adopting it, but be mindful of the ones that you make, because the advantages of using the edge can be lost if you're making a bunch of requests to a very distant origin server all the time. And they also have smaller caches, so you'll have to be a bit more strategic on what you're caching at the edge. I've spoken briefly about there being regional edge caches available for you to use to help give you a little more wiggle room before you have to make a request to a very distant origin server, but it's just something to be aware of. They're also much more expensive, unfortunately, than standard serverless functions. So before you get all excited and you move all your data to the edge and all your application logic to the edge, I would encourage you to take a bit more of an incremental approach, just so we're not surprising our chief financial officers with an unexpected cloud bill at the end of the month. Now, I want to leave off on a note of what you can do today if you're interested in the edge and you want to try it out in your applications. And the best thing that I can suggest starting with is take a look at frequently invoked pieces of functionality that are very small and focused. A/B split testing, setting cookies, setting request and response headers. These are all really great use cases for just moving this to the edge without major re-architecting on your part of your applications, and it will start giving you performance boosts pretty quickly. If you want to take a look at more of the carbon emission side of things as well, I encourage you to take a look at the web sustainability guidelines that the W3C put out about a month ago. They broke them down into really helpful ways, and they also look at sustainability from multiple angles, not just the environmental impact, but even social equity, accessibility, things like that. And I would also encourage you to take a look at the Green Software Foundation. They have free resources, including design patterns, that you can take a look at. So thank you so much for your time and attention today. I really appreciate it. And I hope that you are all as excited as I am after hearing this about the rise of an edge-first future that we're starting to see, and that you start looking to adopt the edge in your own applications. Thank you.